Today we are solving LeetCode 867 Transpose Matrix. This is an easy problem but it teaches a very important matrix concept. In this problem we will learn 5 DSA concepts. How to traverse a 2D matrix, how row index and column index work, what transpose of a matrix mean, how matrix dimensions change from m cross n to n cross m, why being precise with I, j, rows and columns is very important. Let us understand the problem first. We are given a 2D integer array called matrix. We have to return the transpose of this matrix. Now what does transpose mean? Transpose means we flip the matrix over its main diagonal. In simple words, rows become columns and columns become rows. So the element present at matrix I, j will go to answer ji. This is the most important line of the whole problem. Matrix ij becomes answer ji. So let me write this down. Let us take the first example. So input is our matrix equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here the first row is 1, 2 and 3. After transpose this becomes the first column. The second row is 4, 5, 6. Contributes to the second column, second value of each rows in the answer. So the output becomes this. So this is our output. Now let us understand one more example because this is where beginners often get confused. So input equal to matrix 1, 2, 3, 4, 5, 6. So this time there are 2 rows and 3 columns. The matrix has 2 rows and 3 columns, so its size is 2 cross 3. After transpose, the answer will have 3 rows and 2 columns, so the size becomes 3 cross 2. So this is our output. This is very important. If the original matrix has m rows and n columns, then the transpose will have n rows and m columns. Now let us think about the brute force approach. The brute force idea is simple. We can go column by column in the original matrix. For each column, we collect all elements from top to bottom. That collected column becomes one row in the answer. For example, matrix equal to 1, 2, 3, 4, 5, 6. Column 0 is 1, 4. This is our matrix. Column 0 is 1, 4. This becomes row 0 of the answer. And column 1 is 2, 5. This becomes row 1 of the answer. And column 2 is 3, 6. This becomes row 2 of the answer. So this becomes the row 0. Output is this. 1, 4. 2, 5. 3, 6. This is already the optimal idea because every element must be visited at least once. So the best possible time complexity is order of m cross n. Now let us write the exact logic. First, find the number of rows. So m equal to len matrix. Then we find the number of columns. So n equal to len matrix 0. Now we create an answer matrix of size n cross m. Be careful here. Original matrix size is m cross n, and our answer matrix size is n cross m. Now we traverse the original matrix for every cell I comma j. Answer j comma I equal to matrix I comma j. So we do this for every cell I comma j. Notice carefully the row index I becomes the column index. The column index j becomes the row index. This is the whole transpose operation. Now let's write the pseudocode, exact pseudocode. So m equal to number of rows in matrix and n equal to number of columns in matrix. Then we create an answer matrix of size m cross n. Then for I from 0 to m minus 1, we run the loop. We do answer ji equal to matrix ij, and finally return the answer. Now let us write down the Python code. M equal to len matrix and n equal to len matrix 0. Answer equal to, so we initialize this 0 matrix of size n cross m. Then we run the loop to traverse the matrix for I in range m and for each I for j in range n. Then we fill the values in answer matrix. Answer ji equal to matrix ij. Finally, we return the answer. Now let us dry run this. So let's dry run this for this matrix. So here m equal to 2 and n equal to 3. So initially answer will become this matrix of rows, 3 rows and 2 columns, all with 0 values. Now we start traversing. So when I equal to 0 and j equal to 0, matrix 0 0 will equal to 1 and answer 0 0 will become 1. So answer becomes the new matrix. Now when I equal to 0 and j equal to 1, then matrix 0 1 equals 2. So answer 1 0 will become 2, and accordingly the answer matrix will also change. Now when I equal to 0 and j equal to 2, then matrix 0 2 is equal to 3, and answer 2 0 will become 3. Now when I equal to 1 and j equal to 0, so matrix 1 0 is equal to 4. So answer 0 1 will become equal to 4. Now when I equal to 1 and j equal to 1, this time matrix 1 1 is equal to 5, and answer 1 1 will also become equal to 5. Now when I equal to 1 and j equal to 2, so matrix 1 2 is equal to 5. So answer 2 1 will become equal to 6. Matrix 1 2 was equal to 6, so answer 2 1 will become equal to 6. So this is the final answer, and this matches the output. So this is the final answer matrix. Now let us talk about time complexity. We visit every element of the matrix exactly once. If the matrix has m rows and n columns, total elements are n star n. So time complexity is of order m star n. Now space complexity. We create a new answer matrix of size n cross n. So space complexity is order of m cross n. This space is required for the output. So this is our time complexity. And the same is our space complexity, because we need to output a new array. This space is required for the output. Now let us discuss common mistakes. But before that, let us run the code. So let us comment everything out. So test case passes. Let us submit it. Okay, so all the test cases have passed. Now finally let us discuss some mistakes that are usually being done. Some beginners do these mistakes. So first mistake is creating the answer mistake of the wrong size. So some beginners create answer equal to 0 star n for underscoring range m. So that creates an m cross n matrix. For transpose, we need n cross m. So the correct line is answer equal to 0 star m for underscoring range n. Second mistake is writing this. So when we write this answer ij equal to matrix gi, this can cause index errors, especially when the matrix is not a square. The safe way is answer ji equal to matrix ij. Third mistake is assuming that transpose works only for square matrices. So it works for rectangular matrices also. A 2 cross 3 matrix can become a 3 cross 2. A 3 cross 5 matrix becomes a 5 cross 3 matrix. Fourth mistake is trying to modify the matrix in place. For square matrices, in place transpose is possible. But in this problem, the matrix can be rectangular. So we should create a new answer matrix. Okay, so final recap. In this problem, we learned how to transpose a matrix. The key idea is matrix ij goes to answer gi. Original size was m cross n, transpose size becomes n cross n. Time complexity and space complexity both are order of m cross m star n. This problem looks simple, but it builds a very strong foundation for 2D array and matrix problems. Whenever you solve matrix problems, be very careful with the row index, column index, and the size of the answer matrix. That is it for this problem.